Hello again, and welcome to this last part of my MVVM series, part 4, at least for now. I have cleverly avoided to add a /4 here, so I can just keep on going if I feel like it. So we have previously in part 1 dealt with the concept, motivation, different parts and responsibilities of the model view model. In part 2 we saw a bit about how they communicated and interacted, at least the concept, the idea. In part 3 I presented the UML template that is supposed to be usable in your semester projects. And so in part 4 here we have arrived at the code and examples. Right, so now we will actually look at an example and the associated code with it and see how we apply my UML template in a small system. So first a bit of a side note about the binding. So all JavaFX components, may they be buttons or labels or pie charts or text fields or whatever, they have a bunch of different properties. And when I say properties, I mean color, text size, actual text, all kinds of sizes, and enabled and disabled or visible, and so basically all kinds of settings, and each type of setting is held in in what we call a property. So all kinds of settings are available through these properties, and that means we can use our bindings because properties are what we can bind together. So in the previous part I talked about that the controller of the view and the view model would be bound together. So we have this data binding. I can bind a property, some kind of data or setting in my controller, and then I can bind that to the some kind of property in my view model. We'll get back to this, but I just need to introduce the concept a bit more than I have done previously before we move on. So that means two properties can be bound together, and the idea is that a change in one property will be reflected in the other property. And that's the binding between the view and the view model that we have talked about earlier. So for example, you can bind a string property. If I have a text field, then the data in a text field is a string, and so there is a string property for that data, and I can bind that string property to a string property in my view model. And remember that the binding makes it auto update. So if I were to type in something in my text field in my GUI, then my field variable of type string property in my view model would also automatically get an A. So these two are the same here. If I type in a B, then a B will be added to my string property over here. I type in a C in my text field, and again it's reflected over here, and D again. So because of this data binding between my controller and the view model, if I do something in one place, it is reflected and updated in the other class automatically. So that's what all the binding is about, and obviously I will show you the code and we will go more into detail about this, but I just need you to sort of get the basic concept in place. It just means that I could have a string field variable over here and a string field variable over here, and they will also always be the same. If I modify one, another is modified, and if I modify the second, the first is modified. So we just call them string properties. In this case there are double properties and int properties and a bunch of other object properties that you can use, and there are plenty of options, and I think they have thought about just about anything that you might need in JavaFX. So these are the bindings that we have talked about. The properties here, we bind data together. So that's the core concept, and it's a very important detail about the MVVM, and something that also happens when you use MVVM in other languages, for example in .NET. So moving on to my example this is the program that we're going to implement. I have different views that want to present some data in different ways, and then I have my data contained down here. And I just have 3 variables. Maybe in my program I call them X, Y, and Z, but that doesn't matter. And my 3 variables will have a number, and at some point this number might be updated, and so we want the data shown in the views here to reflect the change here. So if we modify that a bit, then it now looks like this. Now the data here might be modified from some external source. It's a bit of a fluffy concept here, but for example in your semester project you may have some kind of data pushed from the server that updates the model, and then we need to be able to update the data presented to the user. Now the update here does not happen automatically in this video series. In later sessions we will combine the MVVM with the observer, and then we can get the automatic updates, and that's actually pretty cool. But for now we'll do a manual update. There will be an update button that I click, and then I get the latest data. So this is the example that we're working with. I have different views and they want to display the data down here. I will not be showing this one. We're going to start with the pie chart, and then we will make this one where I can edit the data. So I can insert some data here and click save, and then it's stored down here, and then I can view it over here. And I have my external data modifier. So maybe this represents some kind of embedded device, external measurement system, some hardware that gives input, or maybe it's your server in your semester project. Or maybe it's a combination. Maybe you have a semester project which is supposed to work with some hardware, but you don't have that available, so you are simulating that the hardware produces input to the system by some kind of class that randomly generates numbers on a regular basis. And that's exactly what I have here, so you will see that in a bit. But we will start out with this here. I will just make a super simple system with the pie chart. So my code example is a bit small, but it's always a balance between showing you everything in the whole wide world and showing you just enough, and then you can expand upon it yourself. So we are doing a slightly smaller example in this video, and then in the exercises we are going to do a bit more. So if I take my UML template from the previous video, it looks like this. I have called my app the chart app. So these are all the classes that I need initially for now when I just want to do the pie chart view. It's not really much functionality for our currently fairly small system, but we have a bunch of classes already, and I have this is not really mine. I just indicate that it's being used, but we have 2, 3, 4, 5, 6, 7, 8, 9 and a file. So basically 10 files here, just to show some data from a pie chart. And obviously that is going to feel like super overkill and way too much administrative work, and the classes will not do very much. But the point is that we practice the template, and then it's easy to expand upon when you are going to get more functionality. Because adding more functionality should be easy enough, as long as we sort of see an example of how to put the first pieces in place. So the point is, if we get this template structure in place, then it's expandable. And in your semester project, you will be expanding quite a lot. Obviously, you will start with a very small system that does very little, similar to mine here, because that is what Scrum guides you to do. But you will be expanding quite a lot on your system. So for now, we practice the template structure on a small system, and then, as you have previously seen in the other videos, it should be easy to expand with the functionality. We start with this pie chart, and then we add the text field view where we can edit the data. Okay, so there's a detail here about the controller. I have added this here. There's a method, just like I have the main method over here. I have a start method inherited from this one, then I have an init method here, and that is mandatory, basically. This is needed because the JavaFX framework is creating the pie chart controller for us, and that means we cannot create our own custom constructor. The JavaFX framework will use its the default constructor without any arguments, so I need some kind of method to initialize my pie chart controller with the data and information that it needs. So all my controllers will have an init method. So after the controller is created by the JavaFX framework, we get a reference to it, and then we call the init method with whatever we need to do. You will see this in the code example. All right, so let's go through the code. I have a plan about showing you these classes in a specific order. I will just escape my presentation, I think. There we go. Okay, so yeah, you might as well watch along. We're going to start with the start chart app. All right, super boring and basic JavaFX. And I have my first example here, and this is the one with the text. I have some other examples that we won't go through. But just to show you what we are doing, I have the start pie chart app, and I call it start because this is where my main method is, so I know which class to go to start the app. I have a specific structure in place. I have my model classes in here, I have my view classes in here, and I have my view model classes in here. That is at least one approach. We'll see that in a minute. So I just have my main method, and I just call this one line of code. This here is the program that you actually want to start. So let's just give it a go and see what we have to work with. And we're just waiting for the compiler. There we go, it's running. Hopefully I get a program up. Okay, I just have it here. So this is what my view looks like initially. This here is printed out whenever there's new data. We'll see that in a moment. I click the update button, and my pie chart is updated with whatever data it had at the moment. I click the update button again, and we see that it is updated, and we get this nice animation automatically. That's just JavaFX beautifying things for us. So whenever I click the update, I get a timestamp here saying that it was last updated at 15/19/34, and I can click the update and so on. I have called my data X, Y, and Z. So that's what my program does for now. Super simple. All right, so that's the start, how we start the system. Let's look at the chart app. This is sort of the real start because it has the start method and what I need to instantiate. And let's open this up again. Let's find the pie chart app. Can I just surprise all inspections class? It was just annoying to see because I have the same code in my other example. So IntelliJ is complaining about, oh, you have duplicate code. That's never a good idea. And IntelliJ is correct. It's not a good idea to have duplicate code because if I change code one place, I will usually forget it the other place. But for now, this is intentional. So, oh, this is a mistake. I don't want a main method in here. In Java 11, the main method must be outside of the class that extends the application. That is the easy approach. You can set up some dependencies to JavaFX modules and whatnot, and it's just easier to create the main method in a separate class. Strange, but that's how it is. So this start method is supposed to start everything, obviously. I start out by creating a model factory. I have that here. I also create the view model factory and give it my reference to the model factory. I create a view handler and I give it the stage that I get here automatically. I don't necessarily need to do that. Sometimes I want to create my own stages. I'm just going to use whatever I get here. that's probably fine. And I give it the reference to the view model factory. So my view handler knows about a view model factory, and my view model factory knows about the model factory. And then I call my own start method that I've created here, and this is basically to launch everything. Down here is where the automatic data update happens. So I just create a new thread, and I generate a random number. No, I create a random object here, an instance of random. I tell my model to recalculate data, and then I sleep for a moment. We'll get to this method later. So this is just what recalculates data. I could have a method that sets data if this was supposed to represent the external source of the data. Then I could generate my data here and then pass it to the model. But for now, it's enough to just say to the model, hey, you should recalculate whatever. We sleep for some random time, and then down here I start the thread, and this here is something you probably haven't seen before, but it just means that this is it's not a sort of a independent thread, but if this thread here is the last one running, then the program will terminate. If I didn't say this, then the program would not terminate, even if this thread was the last one running. So this is a sort of dependent thread that other threads are still alive. It's just, yeah. You'll notice that I used the lambda expression just to make it easier, because I have so little functionality in here that I didn't want to create an entirely new class just to have this. So the lambda expression to shorthand notation for creating a thread and run it. So basically this would be in the run method if I were to create a new class. But we skipped that. So this is to start everything. This was the important part. The data thing here is specific for this example, and you're probably not going to need it. We just create the factories and the view handler, and then we sell the view handler to start everything. All right. So the next class is the model factory, this one here. We're starting out nice and easy because the model factory does very little. So I will open my model factory. I have it in here. I could have created another package called, I don't know, factories. Maybe that would have been nicer, and then taking the model factory and put in, and the view model factory and the view handler. But yeah, it's up to you how you want to structure your system. As long as you do that, use the packages so it's easier to find where everything is located. Again, group by intention or category. So let's look at this one. As you'll see, it does just about nothing. I have a reference to, I have a field variable of type data model. That is my interface. And whenever I want to get the data model, I ask, is it null? If so, then I instantiate it. So we call this lazy instantiation. I don't create my model unless some other class actually asks for it. And then I return it. So this is the interface and this is the implementation. I have called it a data model manager here. I think we like that idea better than model implementation, which I think I used in my previous and also here. This is sort of an outdated naming convention, but call it whatever you wish. We suggest a data model manager or customer model manager or person model manager, whatever, order model manager. And this one would then be order model or customer model, whatever. So it just provides access to this one model. I do this here instead of creating a new one every time, because maybe I want to reuse the data that's in the model. And I want the data model to be able to be shared. So if multiple views ask for a data model, then they should get the same one, usually. So I have maybe a customer model, and I could create a person model, and I would just create another method down here, public person model, blah blah blah, get person model, and it would look very similar to this one here, with the lazy instantiation. So again, this is the part where it seems like extra administrative work and overkill because it does very little. But if you expand upon the program as you will do in the semester project, then you can add extra methods down here, and you don't really have to touch the other classes too much. So we found that this was an easier approach. All right, so the view model factory is super similar. Let's open that up. I find my view model factory, and you'll see it basically does the same thing. I have a reference to it. Now this time around I have chosen to do it in a constructor, so everything is created right away. It's just to show you that this is also an option. Instead of having the lazy instantiation, then I could do an eager instantiation, and then as soon as the view model factory is created, it would create all the view models. That's up to you to decide which approach you want to go. I have a method here to provide me the pie chart view model. When I instantiate the pie chart view model, I ask the model factory to provide me with the data model that I need. Right? If I have another customer chart, customer view model equals new customer view model, I would ask the model factory to get customer data model or customer model or something like that. All right, so the point is I don't need to change my constructor here if I create more models, because they are all available inside through this one. If I instead gave my person model and my customer model, then I would have to modify more classes whenever I expanded on my system. So again, we just give the factory, and the factory here can provide whatever I need. Then we have and I've looked at these four classes and this one as well. We want to look at the view handler. This is slightly more interesting. Let's find the view handler. So start at the top. I have a field variable of stage. This may or may not be needed. If you want to have multiple windows open at the same time, then each window will have its own stage. I just have one window for this, so I'm just using this one stage. I have a reference to the view model factory. I get that through my constructor. And then if you remember here from the pie chart app, I would call start on the view handler, and this is where we actually start everything. So the start method just says open pie chart view. You could do more interesting stuff here. I have chosen to, I could also have this in my constructor, but I have chosen to do it in the start method. Again, because I like my constructor to just set some information, and then if I actually need to do some fancy work, then I do it in a different method. Okay, so my open view method is the method that will open various views. I just have one, but I could open other views in a larger system. And in my example, this is a bit crude, this code here, but we will look in later sessions on how to apply the flyweight pattern to simplify this code quite a lot. But for now, this is what we are going with. I have a scene, it's null. I create my fxml loader, so this is basic JavaFX XML stuff that you need to do. I create a parent object, I call it root, because this is the root indicates that everything in my GUI is contained within the root. I say here to the loader, what is it that I want to load? In my case, it is I can create the string here. So this load here, there's a detail. It loads relative to where this class is located. So here's my class, and I want to load this fxml file in here. So I need to go from here, I need to go into the folder called pie chart, and I give it the argument pie chart here, so view to open. So I just put that to lowercase, that will give me this folder. Then I want to go inside it, and I want to find the pie chart view.fxml, this one here. I chose to do it like this because when I add more views, then I have less code in my if statements. Maybe we'll see an example of that. Then I check if it equals the pie chart, which in my case it always will, but I will in larger systems with multiple windows, I will have else if equals customer view, else if equals person view, whatever. So here I get the controller out of my loader. I have loaded the pie chart view, and upon this loading, the pie chart controller is instantiated. And you'll remember that, so that means, as I mentioned, that I have no access or no control over the constructor in this class. So I get a reference to it by the controller here, and then I call the init method. So just like we saw in the slideshow here, that was the init method. It takes a pie chart view model, and where have we gone? I ask my view model. I should rename this view model factory. Yes, I want to rename the parameter. Okay, good. Now it makes more sense. So my view model factory, I want to initialize my pie chart controller with a pie chart view model. Then I set a title. I have the root here, which is loaded. I put that into the scene. So, and then I put the scene into the stage. So this is a, theater terminology. I put basically the root here is what contains all the objects and scenery on my scene, I guess. In my case, it's all my GUI that is defined in the FXML. So there's this concept called the scene tree, and you don't really know about trees yet, but this is the root of the tree. But yeah, hopefully it's not too important for now. We will use this, maybe some of you may use it later on in one of my other videos. You will see how we can use this functionality for some interesting things. But this is basically how I start everything. I create my view handler through the constructor. I tell it to start everything, and that just means that we open the pie chart view. So in the next class here, my pie chart view FXML, this one up here. So I have gone through these 5 classes. Let's look at how I defined my pie chart view, and I have that not here. That's the other program. Okay, JavaFX. And let's look at this one. So now it's a bunch of JavaFX. It's not all that interesting, but I just wanted to say that you can get a lot of information about what's in here. So one of the things is that you must define an FX controller. Right? You see here Java calls a controller, and there's some implicit black magic that we're going to use later on that requires my class here to be called a controller. So I tell the JavaFX framework that whenever you load this view, I want this class to be sort of spliced together with it. So this is my class behind the view. This is the package path to the class, and then this is the actual class. So you have to give it the absolute path here. So mine would be based on the source. We go to data visualizer. I go to data visualizer 0. I find it in view. I find it in pie chart, and I find my controller here. So this is the class that I want to load, and then in the view handler is the controller that I can get out here, pie chart controller. So this one is important, and if we have it in here, there is the option that we don't have it, and then I can create my own controller and put it into the pie chart view. But I prefer to have it here, and I recommend that you do it, because then there will be some checking. For example, I have a button, and I say that when the button is clicked, I must call the onUpdate button method, which should be located in this one here. And if you don't have the method in your controller, then this will be marked in red and complain. So that's a nice extra feature to make sure that you do things correctly. I also have my pie chart defined here. So, and my label with the I just call it event label. I maybe should have called it timestamped. Okay. We move on to the pie chart controller, this one here. pie chart controller where I have it just here. Yes. And you will see that I have my event label, which matches the name here, event label and of type label. I have my pie chart, which matches the name pie chart, and they must match case sensitive, because then you will automatically get the references in here. I have a reference to my view model, pie chart view model, and I have some data here. Maybe I didn't need to have that as a field variable, but I chose to. So this is the data series for my pie chart. I won't go into too much detail about how to do the pie chart thing. There are tutorials, but basically I can create multiple data series. I call one X and or data parts, and initially the value is 0. So these are the data that must be updated. Every time I click the update button, I modify the data here. I have the empty constructor, which is what JavaFX calls when we load everything, but I cannot use any arguments, so that's why we had the init method here, where I get the view model. This is where the binding happens. So I get my data up here, so I say the X value of my pie chart, I get the value property. This will probably return a double property, so that means it's a property containing double. I call the bind method, and then I bind it to the value that I have in my view model. I just call the bind. There is also a bind bidirectional, so that means if I change something in one place, it will be reflected in the other, and if I change something in the other, it will be reflected in the first. But this here is a one directional bind. I'm not going to change these, so I don't want my view model to observe these. We'll see the example in the second one. But the idea is that whenever my value in the view model changes, then this one is automatically updated because of the bind. Similarly for the the Y and Z values here. I do the same thing for my event label, which was the timestamp. I had the time when the pie chart was last updated. I get the text property because the label contains text or string. It actually gives me a string property, so that's a bit strange they call it text, but I don't know. I bind it, so that means I bind it to the timestamp, also a string property. Right? This is a string property in my view model. So that means whenever the string property in my view model is updated, my event label here will automatically update as well. So I get the latest timestamp. I have an observable list where I put my values, and then I put that list into the pie chart, so this is the list of data that my pie chart must show. Finally, I have the update, the on update button, which was used here. So whenever I click the button, my JavaFX XML file here says that the on update button must be called. So I have that here. If I were to change the name here, we will see that it's now red, cannot find it. So I better undo that. And this is what a lot of your button methods is going to look like. You're just going to tell the view model to do something. I don't send any arguments because the view model will already know most of the data that is needed. So, so this is my controller. It doesn't do much. There's a bit in the initialization where I just bind all the properties together, and then I have a few methods for whenever a button is clicked, and that's it. So fairly simple, and let us move on to the next class, which is probably the pie chart model. Pie chart view model. And we go here, JavaFX. I find my pie chart view model. So in here I define my double properties. So that is a double value containing a property. So this is the data that the view binds to. And the same thing here. This is the property that will contain the timestamp. So in my constructor, I get a reference to the model. I set that up here so I can use it. I initialize my X, Y, and Z double properties, and I initialize my update timestamp label, or my string property here. So this one contains a string, and these contains double information. I have a method here called update pie chart. This was called from the controller, right? Update pie chart. And I get the latest values from the model. I set them in here, and I also get the latest timestamp from the model, and I set it in here. So you will see that there's nothing about sending data to the controller so the view can be updated, because I just modify the data in here, and because of the bindings in the controller, the bindings I have here, then the X data here is observing the X property from my view model, and when this changes, this also changes too. And when this changes, the pie chart updates. So there's a lot of automatic stuff going on here, and I think that is super nice. It makes it easy to work with. And then I have get methods to return my properties for these here. So they are just to get access to these. So my pie chart doesn't do much. I just have access to the model. And then finally, I think the last class is to look at we have the interface. We'll start with that, and then we'll take the model. So the interface here, the data model, it just has get the latest values and get the latest timestamp. So this is what my information my data model can provide for now. Later on we will expand upon it a bit. And let's open the data model manager. I have the data here for the X, Y, and Z values. I have the last update. I have created random so I can randomly generate some new numbers. Whenever I want to get the values from the whenever the view model wants to get the values, I just return my X, Y, and Z in a new double array. And I have a get method to the last update. The recalculate data method here was called from the thread that I started in my pie chart app. So when I started everything, I started the thread, and every once in a while it will tell the model to recalculate the data here. And I just generate some random numbers, and it's not really relevant what it does. I just make sure that the sum of X, Y, and Z is 100, and then I calculated a new timestamp here. This is boring basic Java. So this is what my model does. It recalculates data and provides access to the data. And that is all for my small tiny example with the pie chart, right? So I guess the most interesting part is probably the bindings, right? You're going to take a little while to get used to that, I will assume, because there are so many bindings that it's not always clear what you actually need, right? If I check here, I call for property, you will see that I have a text, I have a label for property, there's accessibility, help property, alignment, background property. So there's information about all kinds of things on this label here. And you sort of need to know what to look for or how to Google it. There's a height property, so I can change the height of my level, my label. I can change what happens when I mouse over the label. All kinds of fun stuff, max width and height, minimum width and height, and so on. So all these properties are things that can be bound to other properties, and then I can change the information in the view model, and then it's automatically updated in the view. So this data binding here is super powerful and makes it easy to work with. And I have come to enjoy the MVVM when you keep your structure clean. I think it's nice to work with. But yeah, we'll see if you share my opinion. Okay, so that was going through the small example here. And let me just continue. So we went through all of my classes. They want to launch everything. They want to create the relevant stuff. My factories, which just provides access to these kind of stuff, and my view handler, which creates the views and switches between them. And then my stuff up here, right? fun things all around. So this was my example. The data is modified, and different views want to show this data in different ways. And some views, for example this one, may want to modify the data. So in my case, the model is shared. It has to be shared, so that's why I have the factory reuse the same instance instead of creating new ones, because I have a view here to modify the data. Then that data should be visible for the other views. It doesn't make sense if they each have their own model. So the model is shared, and in this way it provides a way for the views to share data and to work together. So we are going to, I have my existing example with just the pie chart and my model, and we're going to add this one so I can also modify some data. And let's look at our UML diagram. And what I wanted was to add another view, some other requirement or functionality, and I can do that by just adding the other column here, as I have mentioned before. They both have a reference to the data model, and ideally I hardly need to touch any of the existing code because we're just adding the extra column here. And I may need to add a new method in my model so that we can actually push data to the model and not just get from it. But I don't really need to change much in these classes here. I don't have a new model, I don't start everything in a new way, and these ones, they already exist, there's nothing new here. I need to modify these two classes a little bit. This one will just get an extra get method, so that's irrelevant and there's no danger for breaking anything. And I need to add another if clause up here, so that's about it. And then down here I need to make sure that we can write the data to the model. So in the second example here, we're just going to look at the code for the new ones. That's the idea. So let's go through the changes over here first, and then I think we'll change. We'll see. I will take it in the following order. I have a text chart view, so this is my view for the text chart. Now I might as well just run it so you can see what is going on. I have my data visualizer 1 and I start it with my start. I run the main method, and here we go. Here we go. Go. And come on. There we go. Okay. So I have my two views. I still get automatic updates. I have slowed it down so it takes some time. So now I can update on both and I get the same information, 47 for set. That seems sort of okay. And if I just wait for the next update come here, come on, there we go, I just update. And then I want to update the Y value. That's fairly small, and I want to set it to 75, and I click save, and I click over update over here, and then I can say, okay, 75 is now updated. So I have written some data to the database, or my model, and then this one will view the changes to that to the model. So let's turn this off again. Well, so I might as well just mention while I'm here. I think this one, just so you can see what we are aiming for over the next session when we add the observer pattern. And I messed something up, so you're not going to see that. Tough luck, we'll see it later on. We'll not show it here. So we are going to go through the classes that we're going to modify. Let's see, we will first start with the text chart view. Text chart view. I need a view, and I need a text chart, and I have a text chart view here. There's a bunch of stuff that I don't need. Wonder why that got in here, but well, that doesn't matter. I still have my outer. This time around I'm using a grid pane. Last time for the pie chart I used a V panel, I think it's called. So you just find, so these are about how you organize everything. You find something that works for you. I have my reference to the controller here, Again, data visualizer, visualizer1, view, text chart controller, which leads to this one. So with that, I can automatically load it together with my JavaFX XML. We're going to ignore this part. I have the event label to put the timestamp. I have a button called update, and there is an update button method. So whenever I click the button, this method should be called in this class. I have my X, Y, and Z labels. I have a text fields. I call them something interesting. X text field, Y text field, and Z text field. And I have a save button which calls the onSave button method, again in my text controller. So that's how the view is structured. I used the scene builder to do this. I don't want to write the FXML myself. But let's see, the next class that we want to look at, so we had this one, the text chart view. We want to look at the text chart controller. So how does it look behind the view? Let me find this one. Text chart controller, I can actually just click here. Control click will take you to some class. So I have the GUI elements, right? Again with the same name, case sensitive. So the event label X text field, just like over here, X text field, and so on, so that I have a reference to them and I can alter them and modify them. In my init method, just like the other controller, I get a view model, this time a text view model. I store it in my field variable so I can use it. I do the bindings again here, and the event label, the timestamp update, I just use the one direction bind because I cannot modify this, so I don't want to push data to the view model. But here for the text properties, I have a bidirectional, and that's because as you saw, I could insert text into the text field, and when I click saved, I would push that. Well, when I insert it to the text field, it's pushed to the property, the string property in the view model. But I could also get updates from the database, from my data model. So the update goes in both directions here. So I need a bidirectional. I have my two methods, on update and on save. And again, I just say to the view model, hey, do stuff. The view model will then figure out what to actually do. So I don't need the arguments because the view model knows the data already. And I assume that the next class that I plan on showing you is the text chart view model. All right. So let's take a look at that one. I find the text representation, text view model. Here we go. Again, I have properties to hold the data that must be displayed in the view. I just call them X, Y, and Z. This time they are string properties. So here we see the conversion in play, because the model will provide me with double values, and I want string properties because that's what I put into the view. So I have the conversion between double and string going on here. I have a reference to my model. I have the constructor where I get that reference. I assign it. I instantiate my properties so I can put data in them. Right? So whenever something changes in this property, it will be reflected and shown in the GUI. And whenever I change something in the GUI, by typing into the text field, that data is pushed to my string properties here, all because of the bindings that I have here. Automatic black magic. It's super cool. So when the text control here, if I call the update button, I tell the view model to update text fields. Again, I just get the values from the model. I convert them to strings. I put them into my properties, and because I put them in here, they are pushed automatically to the controller, and the controller will then update its view. I do the same thing with the timestamp. I get the latest one from the model. I put it into to my string property, and again the label in the view is automatically updated because of the bindings. I have get methods to get access to the properties, and down here I have the save changes, and it just tells the model to actually save the data. I get a string value, and the model needs double values, so I just change it. here I could actually do my input validation. So if I, for example, have that the x value was negative, then I would check that here and say you cannot show negative values in my pie chart, so that doesn't make sense. I only want positive values. So we could say that, I don't know, something like this. Doing it on the fly without planning, that's always dangerous, but I will just do like this. I have my x as double. I check if x as double is less than 0, then I want to throw new runtime exception. X value cannot be less than 0. Okay, and I will just declare this one to throws exception, because then that means that I have to handle it here. So whenever I click the changes, I need to surround this with a try catch, and if I get an error here, then I should obviously show pop-up to user with get message. Okay, so this would be a way to implement input validation. I would have to do Y and Z as well, but this would be one way, and I can use the throw exception here so that we can send information back. And when I throw the exception, that is sort of the same as if I had a return statement. So anything after this is thrown will not be executed. So I won't save the data. We just exit the method and go to the catch clause here, right? And then I show something. Maybe I put into the event label that something happened. All right, that was sort of a getting a bit sidetracked. So let us look at the next class. I have the view model in place. The data model interface just needs a small modification, not in this IntelliJ. I have too many IntelliJ's opens. Model here, and the data model. And I have the two get methods from previous example, and I need a way to save it. And my model wants double, and then I implement this new in the data model manager, this class here, and I just take the data out and I assign that, and then I calculate a new timestamp because it has now been updated. So that's the only change I need to do to the model. I don't need to modify any of the existing code. And then I think we should look at the view model factory. Let's find that one. View model factory. And again, I used the approach to instantiate both of the view models in my constructor. I might argue that this is because I know that I will be opening them both at the start of the program, but if you have many windows, then you may not open all of the windows, and you might be better off by doing the lazy instantiation down here in the get methods. So modified the constructor a little bit and added a new get method down here. But I don't need to modify the arguments because I just get the model factory, which we can provide me with all the models I need. And the same thing is true for the view handler. View there. My view handler just gets a view model factory, so I don't need to modify my constructor. So even though I changed this class, it has less impact on my system. I chose to initialize both of these right away. I made it this time around slightly different. If you remember that I had this outside, so here I have more lines of code inside my if statements. So if I wanted to open the pie chart, then I have to do this code. If I want to open the text chart, then I have to open this code. And I could move some of it outside here if I build the string up. But yeah, maybe I will leave that as an exercise to you. But here comes the problem then. If I have multiple windows that I want to switch between, and that meaning opening and closing them, then whenever I open that window, I create a new instance of it, and I just throw away the previous one. And that means that sometimes data may get lost if you have some information in a window and you swap between two windows and you expect to be able to see the previous data. So this is what we're going to fix later on with our flyweight pattern. Or you could come up with your own version. You could do some kind of lazy instantiation if you want to. But the modification to this class was basically just I opened the text view, which simple enough, and then I add another else if statement here. If I want another view, then I would add another else if statement here. I could say I could have a method for opening pie chart, opening text chart, so I could have multiple methods instead. That's also an approach. So that's up to you what you prefer. And I think that is all the code for this one. I talked about the view handler. So we've gone through the changes here, and I hope you saw that the changes to these two classes were very small. This class was also minor, and it doesn't really require me to modify any of the existing code. I didn't need to touch any of these classes here, and these were new. So again, it should be easy to expand upon with minimum modification of existing code if you follow our template here. All right. So last comment about bindings. I have gone through it through the code here, but I just want to reiterate because in my experience this is something that confuses students. Maybe not you, but on previous semesters there have been questions, and basically that's because of the black magic happening, so that properties are automatically updated. So I'm going to try to explain that again, and we'll see how that goes. So bunch of code right in your face. I have the class, my pie chart view over here. I should have called this controller. I forgot to update it. Sorry. This is my pie chart controller, so this is the one that sort of is behind the fxml chart. I have my pie chart view model, and this is the code that you saw in the previously in the video. So same thing. Okay. So the point is that data in the view model is reflected in the view, right? The data here that I want to have in the view and present to the user is bound together here. And that's because of the bindings. And again, I use a one direction bind here. So that means changes to this property will be put into this property, but not the other way around. In my case, I cannot modify X, but I might have some version where I could modify X, but that would not be pushed to my view model if I just do the single bind here. That would require the bind bidirectional if I wanted that both ways. So I have the bindings, right? I bind values in my view together with, in my view controller together with values in my view model. I bind properties together, and the properties contain values. So I had the update button in my in my view, and whenever I click that update button, I would see that I got the latest data. And this is sort of a very elaborate sequence diagram. So let me just frame the code so we are more clear about separation here. So when the update button is pushed by clicking on it on the mouth, it is calling the onUpdate button method. That was defined through the JavaFX XML. Now the method here will call on my view model update pie chart. So that is the method over here, update pie chart. The method will then get from the model the values. So let me just, right, this is the first thing that happens. So let me just find the code for the model. We have that here. All right. The method here is calling here. So it's just a get method. It should return the data contained in the model. then we update my values. Right? I put new values into my double properties up here. So we're just going to swap back again so that I can see my what should have been called pie chart controller. So when I update these values here, right, my properties, because of the bindings, then my properties over here are, or my data over here is updated, right, because of these bindings I have down here. And then when these data are updated, because they are in the list and the list is in the pie chart, then my pie chart, which comes here, gets updated. Right? When I change these, then the pie chart gets updated. So this one changes to reflect the latest data. Then that method path or update path is sort of finished. So we're back here. I changed these values and properties were updated all the way, and the pie chart is updated. And then we go and down to the next line here. My computer seems very slow now to whenever I switch slide. That's interesting. So I want to get the last update, the last timestamp from the model. So let me just find my model class again here. I call the method get last update timestamp, and I set that into the update timestamp property, my string property up here. And when I set something in here, then because of the binding down here, then when I change the value in here, then that value is also pushed into the event label. And when I, right, because of my binding as we have there, and when I update the data in the event label, then that data will be shown over here in my label, so I get the latest timestamp here. All right, so I hope this sort of makes sense. There's a lot of scrolling back and forth between the classes, but otherwise go back and view it again. I have the pie chart controller. It's going to annoy me forever that I forgot that pie chart controller, and I have my pie chart view model and then the model further to the right. So these are the classes that are interacting with each other. So you can see the flow through my code in this small back and forth. So the execution of the update button press here is done. I have updated the data and my view is reflecting that, so I see the latest thing. So this is just about the finish of my video here. I have a bunch of text and I don't think I will read it, but basically it's about the benefits that comes with the MVVM. We have the separation of concerns. It's easier to modify and add to it, which increases long-term maintenance. And we have the clean separation here between application logic and the UI logic, which will make it easier to test. We will see this later on. It is a pattern for XAML platforms. So this is the MVVM pattern that is going to be used in other programming languages and frameworks. And so getting familiar with this will help you if you switch language later on. And it helps the developer design a workflow, so one can work on the GUI and another can work on the model or the view model, because you have the interfaces and the separations of concerns here. And that also improves testability, which we will see later on. You don't have to run your program and click and type in the GUI. You can just instantiate your program with just the view model and the model, and then call methods on the view model to see that everything behaves as intended. So that makes testing a lot more easy, and you can automate it, right? I think that is all. So that is the end of part 4. That became a quite a long video. I hope you stayed awake or at least go back to where you fell asleep. So thanks for watching.